So like I said, I will record this, but I'm not going to post it for a few days. That way you'll have time to do the corrections out of your notes rather than looking at the recording problem by problem. But I will have it posted so you can review for the 11th to do a retake on this test if you like. So we're going to start right out with number 1. Number 1 was asking about, actually let me just pull up the test, probably the easiest. So for number 1, it's asking for 3:18 dilution, what is the ratio of ammonia to water? And this is one that every year I get quite a handful of students on it. Remember, the 3:18 is the ratio of serum, in this case the ammonia, to total. So that means the ammonia is 3, the water would be 18 minus 3 or 15. So a 3 to 15 or a 1 in 5 ratio. That's what I was looking for there. The next two were just testing to see if you understood the meaning of the concentrations. Volume in volume is just milliliters in milliliters. 1 cc, 1 cubic centimeter, is the same as a milliliter. So 22% is 22 out of 100. So 22% volume in volume solution is 22 milliliters in 100 milliliters of solution, or 100 cc's of solution. A lot of people added or subtracted zeros there, moving the decimal point, and I believe it's probably because of the cc's there. 12% weight in volume. Now remember, weight in volume is always grams in per milliliter. So we do have grams and we have milliliters. So 12% is just 12 out of 100. So 12 grams out of 100 milliliters. Now, since the units were given there, I didn't require the units to be given here in your answer. Number 4, we need to make a 1 in 8 dilution of serum in saline. So remember, the 1 is serum, the 8 is total. If the volume must be 160 microliters, what is the volume of saline? So what we really want here is we want the ratio of saline to total. Well, the total is still going to be 8. The saline will be 7/8. If 1 part serum, the other 7 parts have to be saline. Out of 160 microliters, you'll cross multiply and divide to get 140 microliters. Several of you came up with 20 microliters on that one. That is the amount of serum that would be in there, not the amount of saline. You could have used the 1/8 and found the 20, but you'd have to remember to subtract it out of the 160. Any questions so far? Okay, number 5. 50 milligrams of liquid medication is ordered. The dose on hand is 30 milligrams to 2 milliliters. How many milliliters will you get? So 50 milligrams, I put it over 1 to make it a fraction. I'm going to have milligrams on bottom, so they cancel out to 2 milliliters. Milligrams cancel. 50 times 2 milliliters is 100 milliliters. 1 times 30 is 30. That divides out to be 3.33 or 3 1/3 milliliters. Yeah. You could have also used the proportion or the dosage calculation formula there. They should all give out the same answer. Anybody want to see one of the other methods on that one? Okay. Number 6. Cefazolin is to be given in a dose of 30 milligrams per kilogram per day to a child weighing 42 pounds. First, we got to take the 42 divided by 2.2 to get kilograms, giving us 19.09 kilograms. What would be the amount that he needs per day? So it is 30 milligrams per 1 kilogram, and that is per day. So our time is equal there. Equals blank milligrams to 19.09 kilograms. So we're going to take the 19.09 times 30, divided by 1, is going to give us 572.73. milligrams. Now, some of you may have done 19.1 times 30. You get 573. That is perfectly acceptable. Or other variations, since I didn't specify how to round that one, other variations of the rounding would have been acceptable. If you just did 570 because you rounded it to 19 kilograms, that would have been acceptable as well. Calculate the IV flow rate for 80 milliliters infused over 30 minutes. It's asking for here, the key is to look and say that's milliliters per hour. So 80 milliliters in 30 minutes. We need to convert that to hours. 60 minutes in 1 hour. Minutes cross cancel. 80 milliliters times 60 is 4,800 milliliters. 30 times 1 hour is 30 hours. Divide that out, it'll be 160 milliliters per hour. Or you could have just seen 30 minutes as half an hour, so you could have just doubled the 80 milliliters to get 160 milliliters. Number 8. Calculate the IV flow rate for 300 milliliters over 4 hours. And again, milliliters per hour. So all I'm asked to do here is divide that out. 300 divided by 4 is 75 milliliters per hour. Any questions on those last few? Okay, let's keep moving then. Number 9. Order calls for 500 milliliters to be infused over 4 hours. Drop factor is 10 drops per milliliter. What is the flow rate? This is going to drops per minute. So I need to get rid of the hours first. So the hours will be gone. I'll be in milliliters per minute. Now I need to get rid of milliliters and go to drops. 10 drops per 1 milliliter. So the milliliters are now gone. Now I would do some canceling here. I would just cancel a 0 here and here. We'll leave that good for now. So we've got 500 times 1 times 1 is 500 drops. 4 times 6 times 1 is 24 minutes. So it'll just be 500 divided by 24. Or 20.83 drops per minute, or you could have rounded it to 21. Either one would be acceptable. 20.8 would be acceptable as well. Okay, an order calls for 1 liter to be infused over 5 hours. Now, before I even write this down, I'm going to make a change. 1 liter, I know is 1,000 milliliters, so I'm just going to write it as 1,000 milliliters over 5 hours. So again, we're going into drops per minute. So I'm going to get rid of my hours, go to minutes. 1 hour is 60 minutes. Hours are gone. After you get rid of milliliters, they're going to go on bottom to cross cancel. Drops on top, 20 drops per 1 milliliter. Milliliters are gone. Oh, I could probably do some cross canceling here. I'll do the 20 and the 60 to give me 3 and 1. So 1,000 times 1 times 1 is 1,000 drops. 5 times 3 is 15 minutes. So 1,000 divided by 15, give me 66.67 drops per minute. Again, 67, if you rounded it, would have been fine. Next, the flow rate at 30 drops per minute, drop factor of 10 drops per milliliter. How long will it take? Well, I'm looking at this one here. I want to find a time. I'm looking at this one. It has time on bottom, so I don't want to start with that. I want to start it with something that'll give me the time on top. Now, what I could do is, I know that's 30 drops in 1 minute. I could write it upside down like this, 30 drops in 1 minute. That's one way I could go about it. If I did it that way, well, then I have to get rid of the drops. Drops will go on top. I've got 10 drops per 1 milliliter. Drops will be gone. I'm going to cross cancel here. Give me 1 and 3. So I'm in minutes per milliliter. I need to get rid of my milliliters. 900 milliliters. This, I'll put that over 1. Milliliters would be gone. So now I've got 1 times 900 is 900 minutes. 3 times 1 times 1 is 3 on bottom. So 900 minutes divided by 3 is 300 minutes. It's asking for it in hours. So I'll do that conversion. So at 300 hours over 60 ends up being 5 hours. Now the other way we could have approached that is we could have started out with the 900 milliliters. So let me go ahead and do that. I'm going to actually erase this here so I can start over. I started out with the 900 milliliters over 1. I have my drops per milliliter. Gets rid of my 1 milliliter. Then I got rid of got to get rid of drops. So drops are going to have to go on bottom, and I have 30 drops per minute. So minute's going to go on top. 30 drops, 1 minute. So the drops cancel out. And you can see I have the same thing here. If I cross cancel the 10 and 30, I got 1 and 3. It still gives me 900 minutes over 3. So it works out the same. Many of these problems, there's multiple different ways you could start and approach them. But you notice it's still the same numbers that end up on top and the same numbers that end up on bottom, either way. Okay, for the next one. A physician orders a drug at a dosage rate of 60 milligrams per kilogram every 8 hours. For a patient who weighs 190 pounds, how many milligrams should be administered every 8 hours? And how much should he receive over the course of a day? So 60 milligrams per 1 kilogram. We need to convert 190 pounds into kilograms. 190 divided by 2.2. Giving us 86.36. So we will cross multiply and divide to see how many milligrams that is. There's 5181.82. Now that is every 8 hours because this is giving 8 hours. So 5181.82. I believe a couple of you put that in for the day and then divided by 3 to get the 8 hours. Then of course just times 3 to get the daily, 15,545.45. Any questions so far? Okay. Number 13. Physician orders a single dose of 50 milligrams methotrexate for a child who weighs 40 pounds and a height of 125 centimeters. Recommended pediatric dose is 25 to 75 milligrams per meter squared per week. The strength is 25 milligrams per milliliter. Is this a safe dose? Well, first of all, right now, this piece of information is not even useful to us. But let's go ahead. First thing we got to do is figure out the body surface area. So body surface area on this patient is going to be the square root of the weight, 40 kilograms times the height of 125 centimeters, divided by 3,600. Giving us 1.18 square meters. So our dose, I'm going to start out with the 25. 25 milligrams per 1 square meter equals how many milligrams for 1.18 square meters? 29.46 milligrams is the minimum. Now to do a titration to get for the 75, I'm going to do 29.46 times the new dose of 75 over the old of 25. In other words, just times 3. 88.39 milligrams. The 50 milligrams is pretty close to the middle of that, so yes, that is a safe dose. Now, the one thing that did disturb me a little bit here is it does not say 50 milligrams per week. It just says prescribed 50 milligrams. If you said no because of that, if that was your reason, make a note on there when you do your corrections, and I will give you back points for that. Okay. A patient is to receive Oncovin 3 milligrams per meter squared once per week. The supply dosage available is 10 milligrams per milliliter. How many milligrams should the patient with a BSA of 0.65 meters squared receive? So 3 milligrams per 1 meter squared. How much is that for 0.65 meters squared? So we will cross multiply and divide, gives us 1.95 milligrams. Now then convert that to milliliters. Take our 1.95 milligrams and we'll put it over 1. Milligrams on bottom, milliliters on top. 10 milligrams per 1 milliliter, so 0.195 milliliters. Many of you got that wrong, went the wrong direction with that. Okay, we're closing in, just a handful left. Actually, 2 pages left. We're about halfway, sorry. Anyway, number 15. I'm getting ahead of myself. A patient is ordered 0.25 grams. The PO is by mouth. QH is just every 8 hours. The available supply is 100 milligrams per 5 milliliters. How many milliliters should be given? So we've got the 0.250 grams. I would use my metric conversion chart to go from grams to milligrams, which is 3 spots to the right. So that's 250 milligrams. And now I'm going to convert my milligrams to milliliters. This is telling me 100 milligrams per 5 milliliters. Milligrams are now gone. 250 times 5 is 1,250 milliliters. 1 times 100 is 100. Divide that out. 1,250 divided by 100 is 12.5 milliliters. We need to make 400 milliliters of 3% KCl solution by diluting 8% KCl solution. How many milliliters are needed? Well, this is the volume 1 times concentration 1, or concentration times volume, however you want to put it. I'm going to do the 3% times 400 milliliters equals 8% times X milliliters. This is 1,200 equals 8 times X. We divide by 8. 1,200 divided by 8 is 150, and that is in milliliters. That is one where technically you should have the label on it, but it did ask how many milliliters, so I didn't take off points if you didn't. Okay, there are 80 milliliters of 3.5% solution. This solution is added to water to make a total of 190 milliliters. What is the concentration? Same thing again. 3.5 is the concentration times 80 milliliters equals X concentration times 190 milliliters. 3.5 times 80 is 280. And we will divide by 190. Giving us 1.47%. If we rounded to 1.5%, I accepted that. Number 18, an order is given for Enduron 2.5 milligrams by mouth per day. You have Enduron 0.5 groove tablets. How many tablets will you get? Now remember, groove tablets implies we're rounding to the half tablet. If you didn't round it, I was okay with that on this one. But just keep that in mind. Actually, this one doesn't need to round anyway. So you got 2.5 milligrams. And we have 0.5 milligrams per one tablet. So the milligrams cancel. We got 2.5 tablets over 0.5. 2.5 divided by 0.5 is 5 tablets. Okay, doctor calls for phenobarbital, 0.05 grams. By mouth, phenobarbital elixir is grains GRSS per milliliter. GRSS is 1/2 grain per milliliter, like that. How many milliliters will you give? Well, looking at this, first thing we've got to do is we have to convert our grams into grains. Our conversion for that, if you look at your conversion chart, gave you with the test on the back page. Oops, I didn't give you the conversion for grams. That was on the last test. Or maybe I tore it off of this one. 1 gram. I got to remember now. I always mix this one up, whether 1 gram is 15 or 60. I'm going to go back and grab it just to make sure I've got it right. One grain is 60 milligrams. 1 gram is 15 grains. Okay, I was going to guess 60, so I'd have had it wrong. So 1 gram is 15 grains. I'll get this out of the way here. So the grams cancel out. 0.05 times 15 is 0.75 grains over 1. And now we will use that 1/2 grain per 1 milliliter. Grains cancel out. We've got 0.75 times 1 milliliter is 0.75 milliliters. 1 times 1/2 is 1/2. Dividing that would give us 1.5 milliliters. So that one was a tough one. You had to remember your conversion for your grams and grains. Okay, next. Order calls for Motrin 600 milligrams. The drug is supplied in GR5, that is 5 grain grooved tablets. 600 milligrams, we're going to have to convert that into grains. 60 milligrams is 1 grain. So 600 grains over 60, so that is 10 grains. Put that over 1. We have to convert this to tablets. GR5 is 5 grains per 1 tablet. Grains cancel out. You got 10 tablets over 5, which divides out to be 2 tablets. Now, if you had converted milligrams into grams, to get 0.6 grams, and then into 15 grains per gram, it would have came out slightly different. So I would have accepted that as well. Okay, so next, your patient's orders call for Gaviscon 80 milliliters POQID. Gaviscon is supplied in OZXII. That is a 12-ounce bottle. Now I figured I wrote that down just so you knew what it was, but in this problem it doesn't really mean anything because we're not asking how big the bottle is. Gaviscon 80 milliliters. How many ounces is in that dose? Well, 1 fluid ounce or 1 ounce contains 30 milliliters. That's just a conversion off our conversion sheet, and that's all we're asked to do here. So 80 ounces over 30 is what? 2.67 ounces. So this was extra information. You're actually, all you're doing there is really a unit conversion from 80 milliliters into how many ounces that was. Okay, find the final concentration if a saline solution consisting of 40% NaCl goes through a 1:8 dilution. Remember, when we do a dilution, we take our concentration times the dilution ratio to get our new concentration. So 5%. Physician orders 80 milligrams of IM injectable, intramuscular injectable solution, only a vial of the solution with the dosage strength of 100 milligrams per milliliters on hand. How many milliliters? So 100 milligrams per 2 milliliters. Milligrams cancel. 80 times 2 is 160 milliliters over 100. Divides to be 1.6 milliliters. $24. Mr. Jones receives Inderol 100 milligrams by mouth for dysrhythmia. You have Inderol 30 milligrams scored tablets. Again, scored tablets implies, I even said it, round to the nearest half tablet. So 100 milligrams, 1 milligrams, 30 milligrams per 1 tablet. Milligrams cross cancel, got 100 tablets. Over 30, which is 3 1/3 tablets. Rounding to the nearest half a tablet. A lot of people wanted to round down to 3 here because 1/3 is less than 1/2. But you got to remember, we're rounding to the nearest half tablet. So really our quarter mark, or the quarter mark, is our halfway point. So if it's bigger than a quarter, we round up to the nearest half. 1/3 is bigger than a quarter. So we would administer 3 1/2 tablets there. So many of you lost a point on that for rounding. An IV bag containing 1,200 milliliters of fluid is to be infused over 4 hours. So 1,200 milliliters over 4 hours. Infuser is set at 80 drops per minute. Find the drop factor for that fluid. Well, that's in minutes. So the first thing I'm going to do is convert this into minutes. So my hours are gone. And let's go ahead and do some cross canceling here. I'm going to do the 60 and the 120, or 1,200 will give me 20. So I've got 20 hours over 4 minutes. So I got 20 hours, 20 milliliters over 4 minutes, which is 5 milliliters per minute. I'm going to leave it that way for now because I have 80 drops per minute. So the minute's got to go on top here. Drops on bottom. 80 drops in 1 minute. So the minutes are gone. I get 5 milliliters on top over 80 drops. Now we all know that our drop factor is in drops per milliliter. So I'm going to have to flip this thing over, put the 80 drops over the 5 milliliters, and then divide that out. 80 divided by 5 is 16 drops per milliliter. We could have also started out with the 80 drops per minute and gone from there to convert it as well. 2 more left. So doctor orders 3.5 milligrams per meter squared per day of lidocaine for a patient weighing 137 pounds and who's 5 foot 7 inches tall. How much medication should be administered? So again, we got to find their BSA, which will be the square root of their weight of 137 times their height. 5 feet 7 inches. 5 times 12 is 60 plus 7 is 67 inches tall. Divided by, since that's in inches and pounds, it's 3131 that we use in the formula. So the square root of 137 times 67 divided by 3131 is 1.71 square meters. So 3.5 milligrams per 1 square meter equals how many milligrams for 1.71 square meters? So again, it's times 3.5. This is 5.99, or if you had used the 1.71 times 3.5, you might get 5.97, just round off errors. So 5.99. If you'd use 6, that would be fine as well. Recommended dose for medication is 4 to 6 micrograms per kilogram every 8 hours. Label on the vial reads 15 milligrams and 8 milliliters. Patient weighing 165 pounds, find the range of recommended dosage. Step 1 is to take our 165 pounds and turn it into kilograms. So 165 divided by 2.2 is 75 kilograms. Next, we will take our, I'm going to start with our lower limit of 4 micrograms per 1 kilogram. Figure out what that'll be for 75 kilograms. Should be 300 micrograms. Oops. That's not our answer yet. Our answer's got to be milliliters. So we get 300 micrograms here. Now we have our concentration 15 milligrams and 8 milliliters. So that means the 300 micrograms has to be changed to milligrams. Micrograms to milligrams is 3 spots to the left. So we move the decimal over 3 spots to the left. That is 0.3 milligrams. Put milligrams on bottom, milliliters on top. 15 milligrams and 8 milliliters. Milligrams cancel. 0.3 times 8 is 2.4. 1 times 15 is 15. So 2.4 divided by 15. 0.16 is the minimum. And we can do a titration of that. 0.16 times, we used the 4 micrograms, we're converting to the 6. Should be 0.24. I realized I went through that pretty fast. I just wanted to make sure I got through the whole thing today in our 45 minutes or so here. Does anybody have any questions on those that they really want me to go back and explain more? Okay, so like I said, I will save this recording. I will post it after the end of this week. If you guys want to use this information in your notes to do your corrections and get that back to me, I will again give you up to half your points back. And then this will come back then on that last day of class as a way of improving your score if you wish. On Wednesday, I'm going to start our lecture on statistics. We'll have our 5 hours on statistics and our test again on May 9th for that. So you guys, no new homework today, just to give you the time to work on your corrections if you want. You guys have a great day, and we'll see you on Wednesday.